I'm going to run an analysis of variance. And if you recall, an analysis of variance is run when there are 3 or more independent groups and you want to compare them on a specific variable. If you have 2 groups, you can use an independent t-test, but if you have 3 or more, you have to use an Anova. So in this case, we're going to take a look at 3 groups in subject, and this is the subject area taught by a pre-service teacher. Let me just take a quick look at the groups. Math and Computer Science is Group 1, Biology is Group 2, and teachers who taught chemistry and physics, or who teach chemistry and physics, are in Group 3. We're going to compare those groups. So I click on Analyze. We're going to compare means. In this case, we select one-way Anova. Now, subject area taught is the factor. Factor is another word for groups. So that's where the 3 groups are going. And I'm going to compare them on their math software skills. That means their skills using math-based software. And the next thing I want to do is click on Options, and I want to click on Descriptives because I want to see the means and the standard deviations. I also want to click on Homogeneity of Variance. That's important because the variances for each group need to be about the same. If you recall, variance is standard deviation, so we like the spread to be equal. I'm also going to click on this post-hoc test. And it's called Spss, and I'll explain that later, but make sure you click that. And then click OK. So what do we have? Well, the first thing we're going to look at is the descriptives. So we see Math and Computer Science. There's a total of 44 people in that group, a mean of 20.4. And if I go to the range here, it looks like 7 to 28, so it looks like the mean is high. Standard deviation of 5.6. Biology is 36 people, and it's well, if you round it up, it's 3.1 is the mean, 7.9, actually 8 is the standard deviation. And chemistry and physics have 33 people. There's that mean and that standard deviation. Ideally, we like the numbers in these groups to be as similar as possible, and we like them to be over 30 because 30 is where we can be confident or somewhat confident that the distribution is normal, because we're assuming that there is a normal distribution. This is slightly low here. Next thing we look at is the homogeneity of variance. It's a Levine statistic. It's the same statistic used in independent t-tests, and here it says it's 0.331. So it's testing whether they are significantly different. Well, it's not less than 0.05, so we can assume that the variances are the same. So this test is valid. And next, we're going to look at the actual Anova. And what we're concerned with here is the between groups label here. It's between these groups. And we move along. It's 2 degrees of freedom. Remember, we have 3 groups. Degrees of freedom is the total number of groups minus 1. And then there's the F statistic. We had the T statistic with the independent t-test. We now have the F statistic. It's just a different distribution. About the same parameters though. If you have F about 3, it's usually significant. This is 61, so definitely it is significant. It says 0.001. This means that there is a significant difference, P less than 0.001. And so what we know now is that there's a difference between these groups somewhere. We know that there may be a difference between math and biology, chemistry and physics, chemistry and biology, or one other particular, or math and chemistry. We know there's some difference. We don't know exactly what it is. And we can probably assume that math, well, we take a look here, the mean for math and chemistry is much bigger than biology. So probably it's a good guess that those are significantly greater, but we don't want to guess. We want to actually do what is called a post-hoc test. And you remember when I clicked up here, I clicked on Analyze, Compare Means, One-Way Anova, I clicked Post-hoc, and then Spss. Well, that Spss is a post-hoc analysis, and it compares the groups. And so first of all, it's going to compare math computer science group to biology. says there's a mean difference of 17, gives you the mean difference, which is just 20 minus 3, which is 17. And here's the p-value, the significance value. Well, p is definitely less than 0.05. In fact, it's less than 0.001. So we know there's a significant difference between math and the biology group. Specifically, math is significantly greater than biology, not surprisingly, on the use of math software. That's what we're looking at. And then we look at math and chemistry and physics, and there's the difference, but that's not significant. It's over 0.05. And then we've got biology and math, that's flipped around, but biology and chemistry and physics, there is a significant difference too. So let's take a look at this chart down here. What it's saying is that, take a look, we have chemistry and physics and math and computer science. They're the same, those two are the same, but they're significantly different from this biology group. Okay, so that's how you conduct an analysis of variance and read the output.